Talk about today is auth as a whole. This lecture is broken down into two parts. Part one is essentially just getting bcrypt, understanding bcrypt, and seeing how that works. And it deals with, when I talk about auth, we're talking about two different things, right? We're talking about authentication and authorization. Does anyone know the difference? I will tell you, yeah, Jason.
Authentication is, I'm assuming that it's a real web address, that they're a real user, and then authorization is, I guess, once you're in, or once you're authenticated, where you can and cannot put your access.
Yeah, that's a very good explanation, right? So authentication, to sum it up, is just, are you who you say you are? And then authorization is, now that I know who you are, what are you allowed to do, right? So a good analogy of this would be, let's say, have you ever flown, right? Been through TSA, been to the airport? Cool. Let's just say you go to the airport, right? They will check your ID to see, hey, before I give you your boarding pass, are you who you say you are, right? Are you Wang Tron? Great, I have this driver's license, it says Wang Tron, I get checked by somebody, and then they stamp or sign my ticket and says that I have authenticated you, right? Who you claim to be matches who you really are. Now, after I pass security, can I just board any plane I want?
No.
Absolutely not, right? I'm only authorized by my ticket to board one plane from one gate to one destination, right? I can't just, now that I've been authenticated, I'm not authorized to do anything I want inside the airport. Does that make sense? And different people have different levels of authorization. Are there any questions on authentication and authorization? Awesome. So, what we have here, right? I know this GIF is out of control. It's very distracting. You can see you watching it loop over and over as if it's going to change. So, we use something called bcrypt. Bcrypt is best practice within the industry because essentially it would take too much processing power to crack, right? It's not physically impossible. It is just, it would take too long. Cool? All right, so first thing I want to do is in my gem file, normally this line would be commented out. When you do your Rails new, this comes commented out. All I did was uncommented it, did a bundle install because I made a change to my gem file, and now bcrypt is inside my project. I can verify this by simply going to my terminal, getting out of here, and just going into my Rails console, and just checking to see, do I have something called bcrypt? And it's true, right? Otherwise, it would say some sort of undefined constant. Who here has messed with bcrypt, incorporated bcrypt, read anything about bcrypt, or knows anything about it whatsoever? Yes?
With bcrypt, you can use it has security password, for instance. So what happens is it encrypts the password and saves it, and then when they sign up, and then when they log in, it will automatically tell if it is the same password that you use.
Yes.
So if it is true, then you can go in. If not, it's an error. They can't.
Okay, that's pretty good. So bcrypt is essentially a gem. It was written by some pretty smart people. And what it does is it allows us to save information to the database that's encrypted. So for example, let's just say you're on Pizza Hut, right? And you have an account on Pizza Hut. A lot of people do this. We advise you not to, but very often you'll find people use the same password for everything, right? So just because I have a sweet Pizza Hut account, right, my login is your boy and my password is Michael, which happened to be a popular password last year. And then I try to log into my Chase banking app with the exact same credentials, and I get access. That's bad practice. So if Pizza Hut gets hacked, then automatically A lot of people have a lot of other accounts that are compromised, and that would be bad. Does that make sense? So let me ask you this. Do you want to store in your database plain text passwords? Like if I look at somebody's database, should I be able to see a username, and should I be able to read somebody else's password inside the database? Like absolutely not, right? So how can we fix that? How can we do something, right? Because the user is going to type in a regular string, right? How can we take that regular string and make it something that's not really human readable, that cannot be reverse engineered, but at the same time, when compared to the original string, will still tell me whether or not it was true, right? A lot of times, right, this is something known as hashing, right? So I'm just like in the debug, but it's just a regular thing, right? If I had a password called like awesome, right, I can hashify this and just call .reverse. And now it's different. Now it doesn't look like the original password. The problem is this hashing algorithm is very easily broken, right? We want it so that you cannot reverse engineer this algorithm. Otherwise, if I get your database, I can simply run it through an algorithm and it'll spit back out all the plain text passwords. Does that make sense? We want something that you cannot actually do that, but at the same time, check to see if it's the same as the original string. And so bcrypt was invented, right? And that's like kind of how it fixes it. You could think of bcrypt as like a meat grinder, right? Where let's just say I have like a cow, right? And I put it inside this meat grinder. Okay, I have some broccoli, and I put it inside this vegetable grinder. Is that better? Broccoli has no feelings, apparently. The cow is dead, right? All right, broccoli is going inside this vegetable grinder, and I'm turning it, and I'm churning it, and then all of a sudden, I get like this mash at the end. The trick is, can I recognize this green pile of mash immediately upon inspection? Hey, oh, that's broccoli. Can you do that? Like, absolutely not. It's like impossible, right? Well, actually, maybe broccoli because it's got those little florets. But the analogy stands, right? You cannot really recognize it after it's passed through this processor, right? But if I were to take that broccoli and run it through some DNA tests, can I identify that that green mush is in fact broccoli?
Yes.
Right. Can I put this broccoli back in the vegetable masher, spin it the other way, and get back a floret, like a sprig of broccoli? No. So that's what that's what bcrypt is doing, right? You cannot reverse engineer it, you cannot get the original, but you can still check to see if it actually matches the original object. Is that like a decent analogy? Cool. So let's test this, right? So bcrypt gives you something. Boop, boop, boop. Right? It's just a module, right? What is this called? This like double semicolon? It's called namespacing, right? So now we have inside this module, namespace, we have a class, password, right? This is just coming from the docs, and I'll show you how to look up the docs in a second. And all I'm going to do is create something with, please give me a password, and not yours, right? Right, password. Password's great. So if I were to run this, I get something that looks like this. Would it make sense to save something like this in my database? Right. Can you actually read this? No, you can't actually determine what this really is. All right. So really what I want to do is, if I run this again, what should I expect to see? Something different. All right. And the reason there's something different is because of a concept known as assault. All right. Not like assault and battery and like someone fighting, but assault as in like Salt Bay, right? Just it needs a little bit more seasoning. Let's put that salt and pepper, right? SALT. Cool? What the salt is just a random piece of data, typically pulled from like either like date time or something else from your operating system. It's a random piece of data that gets mixed into this hashing encryption. so that even if I'm using the same password as somebody else, I cannot tell looking inside just the database. Does that make sense? So what does this actually look like? Well, let's do this. Let's put password1, right, equals to this right here. Oop. Cool. All right? That's what it equals, right? Can I do, let me just copy this real quick. And can I do password1 equals to this string? What do you think? I'm sorry, I'm assigning, right? Oh, that's painful. I want to compare it, right? Would you think that it would make sense that this is true? False. Let's check. Let's check something. If I were to paste, right, and I were to check what this class is, what would you expect this to be? This one is a string. If I were to take pass1, remember, because pass1 came from this bcrypt class on this create, this must mean that it is a bcrypt object. It is part of the bcrypt class, which is why when I compare them, they do not actually exist. Now here's the weird thing. Can I do this and double check to see, is this comparably password? It always takes a second, it's cool. So, here's what I'm doing. I made a brand new bcrypt object, right? I created a new bcrypt object. I saved it as password1. We can tell that the class of password1 is a bcrypt object. What I did was I compared this bcrypt object with this string, which is what it actually returned, and it did not equal, because a bcrypt object will not equal the string. So I can do, and this is the crazy part, right? I can check, hey, in this bcrypt object that I made, passed it in a plain text string called password, and I compared it to password, it returned true. What this is doing, this is the broccoli DNA test. Even though pass1 looks like this green mush that I cannot actually recognize, I can DNA test it and say, is it actually broccoli? And I can find out that it is broccoli.
You can only do that though because you know what the password is.
Because I know what the password is. If I were to do pass1, and I was like, hey, is your password Michael? And it will say, no, try again. I literally just have to know what that password is. This is why bcrypt is so effective. Yes.
So if we say you had like an array of a dictionary, would you just like iterate it over it, doing a comparison to pass1 or whatever? Eventually, would it? I mean, if your, I guess your password isn't in a dictionary, but like given a way that like numbers and objects, like will it? If it is the password, will it return true every time?
If it is, in fact, the password, it will return true every time. So what you're talking about, and this is a perfect segue into the next concept, is essentially what I can do is I can check pass1, right? I can take this right here, right? I could take this, put it inside bcrypt, and double check it against every possible password, combinations of letters and numbers that exist in the entire world. Eventually, given enough time, I will hit true. This concept is known as a rainbow table. Rainbow meaning like every single color, but here in this instance, rainbow meaning every single word or phrase, right? Which is why people tell you to use passwords like capital H at XOR. It's so much harder to guess something like this than it is to just be like hacker, which is a word, right? It is more difficult to guess at that. Does that make sense? And so that's why they're like, please use numbers and strings. You're like, cool, man. And so now that you've entered the matrix and you understand that, this is why. Rainbow tables will take exponentially longer to guess your password. While it is 100% possible in the realm of the earth, the fact is it would take so much time and processing power to guess your password, the juice is not worth the squeeze. Which is why effectively it is very secure. Does that make sense? So if someone were to be like, hey, you cannot crack it, just be like, okay. As like some sort of like idea, it is crackable. But it would take weeks, months, possibly years to get like one person's password. You can't hate someone that much. It's just, I just don't think it's possible. Cool?
Is that 64-bit or encryption?
64-bit encryption. What does that mean to you? What does that mean to you?
It sounds cool.
Okay. Then I will not answer that question. So, only because if I give you an answer, it just won't make sense. So, is everyone cool so far with this analogy of this broccoli, this vegetable grinder? No feelings hurt. And how bcrypt can emulate this and why it would be good to use to kind of save this hashified string inside your database. Okay, cool. So with that, we'll move on.
I suppose there's more documentation on how to actually put it into your graph. Like you said, it's a module that you call into your class.
A module that you call... Yeah, I literally added the bcrypt gem to my gem file. Sweet. So what we want to do is let's take a look at how and why that is working. Ready? All I'm going to do is put Ruby, and I'm going to put bcrypt. Would you look at that? So good. Inside this, let's take a look at for the first time, digging into somebody else's source code and understanding exactly what's happening. This is a very, very, very useful skill, arguably one of the most important skills to pick up here. Cool? This build is passing, meaning that the current iteration of what this clone repository is that it's good and it's working. There are no known bugs right now. If you see that this is not green and red, and it says failing, some features within this gem might work, but some won't. Just so you have like an understanding of how to kind of go through this, right? How to install bcrypt, I just showed you. I literally added bcrypt to my gem file. I ran bundle install, and that's it. So we can do this. We can create an account. We can authenticate a user. But let's understand why this right here worked. So I'm actually going to go into this and see what is this. In the library, I can check this bcrypt.rb. That's not it. Inside the bcrypt folder, inside the password file, and I'll see the module bcrypt. I should see some sort of class of password. Is that better? Some class of password. Look, it inherits from string. Have you heard or remember, because it's a lot to take in, I get it, the boot camp is intense, from the great and honorable Mike Chang, when he taught you about inheritance, did he talk about something called monkey patching?
Yeah.
Right. What is monkey patching?
Don't do it. Well, it's messing around with the inherent class that you get, or you change the way they operate on.
Anybody?
You can modify class, some of the methods you can call within it.
Yes.
The instance methods of a class.
Yes. You can modify literally anything you want in Ruby. It's magic. I can literally go into the class string, right? Do you know this method called 2s? I'm gonna take anything and like 2s it, make it a string. I can literally go into, let's see, ready? You guys wanna take a look at this? Does Mike Chang actually monkey patch something for you?
Sure.
He did? Do you want me to go over it again or no?
Yeah.
Okay, sweet. So I can open IRB, literally go into class string, literally call the 2s method, and then have it do g is for gains. and the class string, and then now I could take the, what, I don't know, something like cool, right, which we know is part of the string class. I can do cool, call a method called 2s on it, and then, that's embarrassing. End quote, right? I can call literally cool, or not, call a method called 2s, and it will say G is for gains. I've literally overwritten the 2s method. Once I leave the IRB though, it will pull back the regular Ruby. But I can monkey patch this. So if I put this in my code, based on the way inheritance works, it will look inside my class first and then up the inheritance chain for methods. So that being said, if I have a class password that's inheriting from string, wouldn't it be nice if I had a method and I overwrote the double equals? So the double equals that you know, that is the comparator on the string class, when called on a Ruby object, will not be the same as if it's called on the bcrypt object. Let's take a look at an example of this. Boop, boop, boop. Okay. Let's do this. So I have pass1, and I can do bcrypt. You got a cool password for me? That is the coolest password I've ever heard. Pot. Potatoes. I just realized that I don't want that to go fully on the recording. Right? Cool. Remember, this is the string. Right? I just copy this and put it. If I do this, it is the comparator that you know and love. If I compare it to pass1, what's going on? I'm calling the normal string comparator, right? Because here it's calling it on what? On the string. Here I'm calling it on the bcrypt object. So this double equals is syntactical sugar for just pass1 dot double equal with an argument of this string. Oops, dang it, embarrassing. Of this string. And that's how it's being called, right? So don't be fooled by the syntactical sugar. It's just a method being called on a class, on an instance of a class. Cool? Are there any questions?
Wait, so does this method come built in with the gem, or do we need to define it in our controller or class?
Which method and
The equals, the two equals method for bcrypt.
okay, maybe I wasn't clear, right? So here we are literally pulling from the module bcrypt, right, from the class password, which ultimately comes from the bcrypt Ruby, right, which is the gem that we installed.
Right.
So when we gem install bcrypt and I use bcrypt, I'm pulling all of the methods, all of the code. This is, when you do gem install, you're literally copying and pasting this code inside your code base. That's what it's doing. So when I dug through the library and went to the password file, that's what I should have access to inside my Rails project because I have the gem bcrypt. So every single gem will have its own repository, will have all its own files that you're copying into your project. So when you build Rails new, your project, even though it may not feel like it, is already inherently massive.
So when we store the hashed password in our database, what is the properties of password?
Yes, I'll get to that though. Don't worry. Cool. So, is everyone cool on that double equals being overwritten and how it's being called? Awesome. So, here I have just a regular old application, right? Following the RESTful routes, users new. I can infer what two things regarding my model and regarding what view I'm seeing. Well, I have a user's model, right? That's the first thing.
Is that new too?
And I'm seeing the new, right? The RESTful route for new for the user, right? Cool. It's a pretty simple sign-up page. Let's actually take a look at what that looks like. We talked about the user. Oops. We talked about the user having a new. And all I did was do this form for. I have this @user, which is following best practices in this new, probably like an empty user object, right? Remember, this is calling username, sorry, not the label. This is calling @user.username, and this is calling @user.password. Are there any questions on the form for and just remembering that? Cool. Let's take that into account. I want to make sure you see something that's really important, and that is this. In my schema, I have what in my schema under the user? I have username and I have something called password digest. Why would I have something called password digest and not password? Well, let's think about this. Do I want to save that plain text password, or do I want to save a hashified, digested version after it's run through the bcrypt engine, hashified string into my database? Which one is it? Sweet, right? So it's the hashified version. It's a digested password, right? This is the convention when using bcrypt, and it must be password digest, and you will understand here shortly why. Cool? So remember, I have something called username and password digest. Back to the new form, I will be calling @user, username, and @password on @user. Will this work for me? Well, let's find out. Let's find out what happens. Let's take a look at the controller real quick. User's controller. I just have a show and a new and a create. I've dropped this by bug just so I can pause it right when it hits here. God bless you. God bless you. Cool. So, following that, oops. Cool. Following that, I have a username, right? Yeah, my seed data is terrible. I squirrel, who cares? Password, right? What's like a cool password? S? Nests. Cool. You see these like password dots here? I got that because I used inside my new, I used something called password field and not text field. Cool? There's a bunch of different fields that helpers that Rails will give you. Just be aware. Sweet. So when I hit create user, what should happen? I hit the buy bug, right? Bloop. And matter of fact, I hit the buy bug right inside the create, as I said I would. So naturally, I'd want to know, can I do this user.create user params? Well, let's find out. So copy, actually, I'll just copy this whole line. Copy, paste. And it says, unknown attribute error. Unknown attribute for password for user. Why would that be?
Because the attribute is password underscore digest.
Yes, because the actual attribute is password digest, right? Here we see I'm trying to save it as password here and not password digest. That's what my strong params are saying. So that being said, remember active record will build you, right? Reminder, right? This is kind of important. Let's look this up. Where's the key? Oop. Important. That active record, whoops, that's not how you spell that, will build you getters and setters. All right? What does that mean? What that means is, if I have a username attribute for my user, it will build the getter so I can do something like @user.username I don't actually have to manually do this, def username, right? Simply returns username. Seemed like so long ago, right? That being said, in the exact same way, if I have something called password, right? This is the getter for username, right? What would the setter for password be? Password equals, and then I have to pass in, right, a plain text password, right? So I don't need this getter because active record will build me the getter and setter for username. It did not build me the getter and setter for password. Why? Because my attribute name inside my schema is password digest. So what we'll do here is inside password equals, all I'm going to do is drop a bybug. Cool. We don't need this. This is just a reminder of those getter methods. And all I'm going to do is, oop. I'm just hitting refresh. Sometimes Rails is a little slow. Yeah, it's definitely Rails. Rails. Cool. Rails. Guess what that password is? Rails. If I hit create, I'm going to hit what? The bybug here. If I were to do the user create with the user params, it's going to take the username and the password params that I submitted and attempt to write them into my user model. Meaning, earlier when I got the error that said unknown attribute for password when I try to create it, I now actually, in fact, have a setter method for password. So when I try to create this user with the password attribute, it's going to find the method and it will hit this bybug. Oops. Embarrassing. Okay, just kidding. Just kidding, sorry. It should hit this bybug.
But it's not password digest.
Yeah, but it should be trying to save password. Okay. The analogy's lost right now. It's not really important. The important thing is, inside this, right, password equals that I'm trying to set, what is self? It's the @user that I'm calling it on, right? Yeah? Do I have access as the user instance to password digest? Right, and right now it's what? It's nil. It's nil right now, right? Can I assign it using the setter method? Does this setter method exist? It does, right? Because active record built it for me. So what I want to do is in this password digest, I actually want to make the bcrypt password here. With what? Oh, nah, that's not gonna work. With what? The plain text password. Does that make sense? That way, when I run this password equals method, I'm going to get inside my password digest a bcrypt object. So it'll save and it'll be hashified and it won't be really readable. The next thing I want to do, right, is part 2 of this lecture will be that authorized, where we'll build in that login form and we'll check to see who the current user is, who's logged in. But let's just say we have that for now, right? And the first thing I want to do is when I submit this login page, this login form, I want to do what? Do I want to authenticate or do I want to authorize them? I want to authenticate them, right? So naturally, I want a method called authenticate. Nailed it. Good job. What should I do in here? Well, you guys want a break? You guys need a break? Okay. So what would I want to do in this authenticate method? Knowing what I know, right? Because some of you have already used devise or planned on it or have already implemented auth and have claimed to me that you understand it. Please help me.
Well, I would think that you want some type of conditional that checks if the things submitted match what's stored in the database. And then if it does, it allows you to test it.
Right. So what I'm going to do is, what's going to wind up happening, right? And like, let's just say this, we have the user controller, right? If I'm logging in, if you remember from yesterday's lecture, I created what? Not the Flash, but the, naturally I would have some sort of sessions controller, right? That's going to create a session for me, for my user, if they're logged in. The login form is going to hit my sessions controller, right, with a custom route pointing to sessions and something like, I don't know, maybe def create. Oops. Because I'm actually creating a new session. Yeah? So in here, all I'm going to do is what? I have access to my params from the form. So here, I would have access to the params. I would do something like user.find, find by the username, right? And that's going to be the params of what? Username. Because I just submitted the form to try to log in. Right? And that form just has what? It's a form tag. And it just has a username on it. Just trying to think through, right? And then what do I want to do with this user? I want to see whether or not this user is who they say they are. And I pass in params of password. Because it's coming from the form, right? It's the username and the password. Those are the only two things in login. So I know that this authenticate checks their plain text password. So in my user, I have a method called authenticate that takes in a plain text password. And here, what happens? Well, I want to check, right? If we remember in the magic of, bcrypt. Actually, I have access to bcrypt here, right? Yeah. I can do password. Remember, I have this like salted password, right? And it's simply a string. I don't want that string. I want the bcrypt object. Does that make sense? I want the bcrypt object in order to use the bcrypt comparison double equals, not the string double equals. So how can I create a new instance of bcrypt password? Not exactly, but you're very close, right? I want to create a new instance, right? I don't want to create, because create is going to what? Add in the hash and make a brand new one. And as we looked at earlier, if I check the create against another create, they're different and they will not equal. So I simply want to use new, and I want to pass in what my user actually has, and that is the self.password digest, right? Because that is the string that's like hashified and all weird. And then now that that is a, God bless you, bcrypt object, I'm going to use the bcrypt double equals to compare it against the plain text, whoops, the plain text password that was passed in from authenticate. Does that make sense to you? So, in my authenticate, I'm going to make a new bcrypt object with the password digest that I just created using the plain text. I take the plain text password from the authenticate method that I'm calling, and I'm simply going to, compare it against the plain text password that I was given.
So in the password method, the bcrypt password.create is what's creating that string, the weird string, or not, I don't want to call it a string, but
The dot create is creating that hashified string, yes.
right. So in now the authenticate method, we are going to pass in
That hashified string.
hashified string into this dot new.
Yeah, because all I want to do is create the object with this hashified string, which allows me to use the bcrypt comparator.
Right.
Because we don't want the string comparator, we want the bcrypt comparator. So this is going to give me a bcrypt object with the same password digest that I got from this. So it's going to be the same one.
Is it in essence converting, authenticate is converting? I know it's obviously checking, but the first part before the two equal signs, it's converting a string to an object.
Yes.
And that string is that absurdly long thing we got.
Yeah. And now I'm comparing it to what was passed in. So what I'm saying is if this is good, right, I want to give them back the user object, right? Like, hey, are you who you say you are? Yes, cool. Return the object. Otherwise, false. You are not who you say you are. Authenticate should fail. Are there any questions on this? Okay. Great. This right here, who likes being upset? Okay. Me too. As mentioned earlier by Ruth, if I use something like has secure password, it will build these for me. It will also add a validation that the password must be true, right? Presence is required inside the user object. Are there any questions as to the authentication portion of auth, what's happening under the hood and how it's working, and then how ultimately we'll use this exact code, all right, which is like given here. Thanks Rails. Yeah. Yes. 1 second. The reason has secure password works is because it's expecting password digest exactly as a column inside your schema under user. So you can't use something like password hashed or hashed password. It must be named password digest. And to bring it full circle for the user, I'm keeping password in here because when I'm trying to write to my password, I want to take the opportunity before it's saved to make it a bcrypt password. That's why the column name is called password digest. I want to intercept it when I'm overwriting the password, set password digest to the bcrypt object. That's why it's named password digest, and that's the only way has secure password will work. So when you follow your tutorial and it says create a user table and give it like a username, an email, an age, whatever, and make sure you have something called password digest, that is why. Because it's expecting the attribute to be named password digest. Hopefully that has helped you. Are there any questions? Sam?
If we want to have password confirmation, we have to overwrite the validation.
You have to override the validation, yeah. Because it comes out of the box with has secure password.
Has secure password and then validation manufacturer.
Where again?
So I was just curious, like, so in self.password, like, how does it know which user instance it's kind of checking against? Is that one be? Is
Okay.
That
This is like a mod 1 thing. These are class or instance variables.
those are instance variables.
Okay, so you can only call instance variables, instance methods on an instance or class.
On an instance.
Great. So when I call self here, it will be the instance that calls it. So when I'm in new, right, at user here, when I'm trying to set the password, this is the instance I'm going to use. And then when I do the login for the authenticate, right, inside my sessions controller, it will be this user I'm trying to authenticate. Cool? That's why self is important and why it scales. All right, that's all I got for you today.